Hey guys, welcome to my talk. Today we'll be talking about effective dependency injection with multimodal architecture. I'm Adit. I work for a company called Gojek. We are a super app based out of Indonesia, and we are live in multiple countries. In this talk, we are going to be talking about a bit of where the DX is going to be used. Sorry about that. And yeah, sorry about that. Yeah. So a little bit about myself. I'm Adit again. So I work for a company called Gojek. We have about 20 plus products ranging from food tech, we do delivery, we do fintech, we do hyperlocal delivery and a few massage services. We also have a payment gateway. We do about $6.5 billion worth of revenue, and we have hit about 20 million kilometers of ride using a ride sharing application. Right now, moving on, there's this kind of a problem statement out there like, hey, how do we manage our application? How do we balance the act, right? Now, a few years back, what has happened is that the architecture was way different than what we see today, right? There are multiple architectures out there now, in the mobile as well. And a lot of people still behave, or rather, a lot of people still use a monolithic architecture. But what is a monolithic architecture? Most of the applications have a lot of features, right? So we have some kind of a dependency as such, and we have two features, and over a period of time, we'll grow into 3, 5, 10, whatever, right? Now, what happens is that there's always going to be a core object that gives us, expensive object that is very expensive to initialize in our, let's say, cold start of the application. A cold start over here is nothing but when a user clicks on your app from the launcher, and it's a brand new initialization of your application. Now, this expensive object could be used in multiple features, or it could be just used in one, but it's still utilized, right? Now, the problem with all of this is that it's a straightforward application architecture, but as you grow further, the dependency graph increases. There could be something that you need at runtime, but it's provided at the app startup, and you need to transgress through the cyclic graphs to get this dependency. So in this talk, we're going to be taking a look at how we at Gojek solve some of these problems, and how did we achieve multi-modular code for our application. Now, before we begin, what do you think could go wrong, right? You could be asked like, hey, everything works flawlessly, and A, B, C, everything works, right? But there could be one manager coming your way and saying, hey, here, would you like to build this, and could you give me an estimate for it? And you'd be like, yeah, sure, it'll take me 2 days, 3, whatever. But as you start writing your code, you realize that there's so much of back and forth that you need to talk to the right person who owns that particular dependency that you need. But now you don't have that access, or that person is giving you a few tips and tricks of how to manage state, right? Now, given all that, I think it's a lot more easier to manage multi-modular going forward. So let's try and solve dependency injection with our multi-modular code base. To begin with, what is modularization, right? In a classic example, a non-monolithic Android application would take a bit of a different approach. There is no need to kind of bring down everything from app module to your feature module, or have everything initialized in your app. You could take it from initialize it in one module and then bring it down to your feature module when required. Now, there's no godlike object here, or there is no knowledge of knowing how to initialize stuff. It should be all handled, by the way, from how things are initialized at start time, right? And for example, let's say feature A needs something. It doesn't come online, or it doesn't come to the stage until, say, a user clicks a particular screen and that gets navigated to that feature. Now, when this scenario occurs, you need a hell lot of dependencies. So which all dependencies do you need? Can you scope it? So there are a few things that you can modularize here as well. We'll be going over each of these and some of the pro tips that you can take from this particular talk. Now, given that there is a lot of congestions here, right? As you can see in my diagram, there are a lot of things that are going to happen when you create a new, or you construct a new module from ground up. There are a lot of things that you need to initialize. So let's take it one step further. Let's put it in a diagram format. Let's say that we have a feature module called app, which means, or this is the starting point of your application, right? You have your splash, you have, say, something like a login, and then you go further to your overall application. Now, obviously, we have an expensive object that takes a hell lot of memory space and it takes a hell lot of initialization bulk of time, right? Now, this remains as is. We have a module called Cove that provides us this particular dependency. Now, if you realize from the previous slide that I showed you, the app depended on core, and then feature A and feature B, or feature 1 and 2 in my example, would then have to do a lot of crosstalk. So instead, we'll still keep the app dependency with core. Dependency over here, or the green line that I've drawn here, is a Gradle dependency. But rather, now I'm moving the features above the app level. Now, when I do this visualization, what's happening here is that feature A or feature 1 is basically talking to app and saying, I have something that I need from you, and I don't know who's going to provide it. I just need it, right? Now, when feature A comes to life at runtime, we are expecting expensive object to be pre-initialized and delivered to us. Similarly, at level of feature B, we expect the same. Now, this app module depends on a core module, which contains shared code and resources. It could be one expensive object, it could be more, but all the dependencies are passed through app module at this case. Now, a few thoughts on modularization. You can organize and decouple independent pieces of functionality. Now, what I mean by that is you have to go and take a granular look at your source code. If you have a monolithic repo already, or if you even already have a multi-modular architecture with your current project, you need to also take into account how you're going to decouple certain things. Like there are independent pieces that can be initialized beforehand, or it could be initialized at runtime. So what are those? Can you identify them? Can you initialize it at runtime? And can you scope it at a particular time? Next, we improve the project build times by modularizing. What I mean by that is there are modules that don't need to be initialized at start. They could come in at a later point, or the dependency graph can be initialized at a later time. So we do a lot of lazy binding as well. What I mean by that is some features have very simple interfaces that talk to the app layer, and app obviously knows everything about, say, feature A and feature B, or feature N for that matter. And we try and only initialize things that are required at runtime. Now, we also define clear ownerships. Now, if you realize our particular app, Gojek, has 20 plus products. So each product has a lot of source code that needs to be initialized and a lot of dependencies to be managed. And we obviously have a lot of modular, Gradle modules. Sorry for that. Now, we have about 150 plus modules, and each of these modules are going to be unique in their own retrospect. When I say they are individually managed, what I mean by that is that each team now has some control over it. Not everyone controls each other's modules. So if you can define a certain graph of who owns what, that'll be really, really important here. Now, a few key points about feature module. It's owned by a single team, maybe a set of team members. You can decide based on the criteria that you choose best for this particular module. Or it could encapsulate a single feature. It could be a sum of two or three things that you as a product or you as one feature module does. Or it could be just one thing that has one activity, one view model, and whatever. I mean, you do your business logic inside it. Also, do remember that this is a single entry point. I would advise you to kind of build your feature module based on a single entry point because it gives you an ease to initialize your dependencies a lot better. Next, the smaller the better. If you expansively think about it, like if you start creeping in a lot of business logic into a single feature, then you're also investing a lot of time to build that particular module. So if you can keep it light and simple, the feature module will actually kind of help you moving forward. It will actually help you in your build times as well. Next, you cannot really depend on other feature modules. If you need something to be initialized from, say, feature A, and say something like a navigation has to go to a screen called feature B, which is present in the feature B module, it's not really your headache to manage that feature B dependency. You would rather have a navigation graph that would then talk to an endpoint called, hey, I want to go to this screen, and you don't really write a Gradle dependency on that. Next, when it comes to app module, there are a few things that you can take a note. There should be no feature-specific code. It should all be, think of app as a binding logic. Everything comes together, right? No infrastructure-specific code. It should not do anything very specific to how to initialize stuff, or it should just know, okay, this is what I need. This is what is going to be provided to me, and this is what is going to be given to me. and this is how I'm going to initialize stuff. That's it. There should be nothing called I'm going to initialize this tree graph or a dependency graph based on this input. It should not do those. Next, app should have some basic Dagger component. Like if you realize with Dagger, there's also a single entry point. Somewhere in the app application process, you're going to say, hey, this is my base or the core or the starting point of my Dagger tree. Now, this is where all the dependencies are going to be initialized. There could be something like, say, retrofit. There could be something like network preferences, maybe a DB that is globally accessible across all features. All those things are going to be initialized somewhere. So this is where you're going to create a component. This is what an average Gojek code base looks like. We prioritize this based on certain themes. So we have color coded them. So depending on the color, you either own it or you have some shared dependencies. Now, what we have here, the app is what generates the final APK or the final app that goes out into the Play Store. And all of these are then modularized in such a way that if certain features are not available in certain countries, we don't build that APK with those features on. Now, there are a few things like common, core, auth. These are just examples to show you that we have obviously some common utils across features. So all of these are sort of pseudo dependency graph. Now, moving on with IOC principle, there's a lot of things that people don't realize with that, a dependency injection is that you need to know this principle pretty much before you start with a framework like Dagger or even Coin or any other such things. Now, how to define like a dependency injection for a 5-year-old? Now, when you go ahead and get things out of the refrigerator for itself, right, you can cause a lot of problems. You might have the door open. You might get something that your mom or dad or maybe your roommate might need. And you might also be looking at something we don't have and which is already expired. So how do you know what's inside the fridge, which is a closed door? And how do you see what's inside, right? Now, what you need to do is that I need something to drink with lunch. And if that's the statement, you expect someone to come like a genie, let's say a genie of a bottle. You say that, hey, I want something to drink for lunch. And it magically appears for you. Now, how do you do that? Now, when you get that object, there's obviously some mechanics behind it, right? There's that magician that's providing you that. Now, obviously, that fellow needs to know how to initialize it or which fridge. Let's say that your fridge has, say, 5 Coca-Colas, and you didn't explicitly say which drink you want. And there are few, say, for example, you have few water bottles, but it magically provides you that. So you need to be explicit at times. Now, that is what this IOC principle is about. Dependency injection, inversion, and inversion of control. You explicitly say what you need, but you don't tell how to initialize it, or you don't explicitly say who's going to provide it to you. You say that, hey, I want this, and I'm going to be asking for this at this time. So the dependency graph or the tree is going to provide it for you. Let's take it a little further. Few tips to kind of remember. We declare components that can be reused. A component should not be something that you just use and throw. It should be something that you can keep in place so that if someone else comes and asks for a certain dependency, a component can provide. In the Dagger world, a component is what provides or binds a certain dependency, and depending on the scope, a client or a consumer call site will get this. Next, high-level modules should never depend on low-level modules. If you remember the visualization that I showed you before, high-level modules are something that are aware of how to bind it all together, but don't really know who's going to provide what. They just combine everything together when required, they will provide for. Next, build abstraction, so any implementations can be easily changed with a new one. Now, what I mean by that is that if you can build a bit of flexibility with your code base, now if you have something, say like, I want to provide this retrofit with a base URL initialize, a very common problem statement, right? In most of the applications, you just need one base URL and you have multiple endpoints. But in some applications, you have multiple endpoints, multiple base URLs, and depending on the feature that you're using, you may need a different or rather a mutated version of it. So instead, if you can build, a mutation or rather an abstraction of your dependency in such a way that you can get the implementation version of it or the implemented version of it, and then add something on top to mix and match to your requirements. So always try and keep abstractions. We'll take a look at how all of these points come together. Next, dependencies can be injected into components. A lot of people don't realize that A component can depend on someone else to provide a dependency that this component can then provide further down the stream. So remember that you can actually depend on some other component to provide something that you don't know how to initialize or you don't know how to bring about. Next, a big question a lot of people ask, a lot of folks say, hey, should I modularize just to use Dagger? Now, modularization is one thing, but then Dagger is another concept. I would say a big fat no. You don't need to modularize just to use Dagger, or you don't need to use Dagger just to modularize your code. You can have a simple app module and have everything initialized. You can have package-driven features. You could have module-based driven features. It's all up to you. And the next question could be, don't do it for Dagger, right? Or rather, do it for yourself. I have this immense feeling when it comes to when I work with Dagger code. When you initialize something, you obviously are, especially, for example, at Gojek, we have about 40 to 80 member teams, and they are split across multiple code bases. What I mean by that is that there could be some feature modules that some team members are working on, whereas I don't have any context of it. And there could be my team members that are working on certain contexts. So how do we share dependencies? So we choose Dagger because it's easy to manage and it's one of the most popular frameworks out there. We also write a lot of abstractions over Dagger code. We don't directly build on top of the framework. Next, let's put all of these points together and visualize how a Dagger code would look like. Now, all the white boxes that you see on your screen right now are basically a Gradle module. Core is what provides the expensive object. So with Dagger code, if you've worked with Dagger, you know that we have to write a module and a component. So we have those connected. Next, your app module has main module and main component. Now, these two together are dependent on the core Gradle module. Similarly, feature one and depends on core. This is usual way of writing code. So app knows about feature one, but feature one needs something called expensive object. So you obviously have that dependency over there. Similarly, with feature two, you have the dependency of app knowing about feature two and feature two knowing about core, and that adds to your time, the build times, and it creates a lot of cyclic graphs. To avoid this, you should do something of this kind. Feature one should only know or rather depend on core, and feature two should only depend on your core. Whatever it needs, it can get it from the core. Now, when app initializes, it says, hey, I have to initialize and trigger this feature one. We have certain things called deep links that manage our state of affairs when we are navigating to a screen within feature one or feature two. So app really doesn't need to be connected to feature one and two in our case. Now, the biggest gotcha that we kind of advise a lot of peers and few folks that I've interacted with over a period of time is that do not use subcomponents with Dagger. The reason we say this is we should prefer to be very explicit with model dependencies. The more you write about subcomponent, the subcomponent knows a lot about your parent component. So imagine writing a feature one subcomponent. If I go back to a previous slide, if you realize there's a slight difference here, there is subcomponent and versus something called as component. The difference that adds to here is that a component doesn't need to know anything about what it's dependent on. It can get the graph at runtime. Next, we also don't want to write core component to know about feature component. Now, when you write subcomponents, the core component, the dependency for the subcomponent will know too much about the feature. And that is not what we want. We want a top-to-down approach. We don't want the core to know a lot about what's happening on feature level, and we don't want feature to know a lot about how to initialize something in core. Next, we can't really check if the graph is correct with, say, something with a subcomponent, because we just blindly accept whatever component is providing, I get it as is, right? And just remember a point that subcomponents really needs its parent to tell everything for it to initialize. And that is almost equivalent to slow compilation time. If you can remove the sub component, then everything is going to work for you pretty fast. Now let's look at some of the code base here. We have core module, which provides a singleton called expensive object, right? Now we manage it via singleton scoping because we want it to be there as long as the process is available to us. Similarly, with the component, we have a builder that builds everything and we expose our dependency to whoever wants it. Now, when it comes to our main application, we are obviously going to write something like this. We're going to be starting the trigger point of core component in our application code. And we're going to be providing that core component to say something like our activities and fragments and whatnot, right? Now, this code is great, but we have used a generated Dagger class. We've used the builder to build everything that we need, and we're initializing the core component. Now, in a companion object, we are going to be providing it to anyone who asks. Whoever wants core component can get it through this. Now, this is great, but let's take it one step further with Kotlin. So here I have an extension function called activity.coreComponent, which basically calls that companion object function called myApplication.coreComponent, and we give it a context, and in return, we get a core component pre-initialized. Now, this is all great, but let's take one step further. Let's say we have feature one module, which provides, say, something like a string, just for the sake of pseudocode. And feature one component has, again, a builder that needs core component to initialize something, right? And if you realize, we have our dependency. Sorry about that. We have a dependency on core component. Now, feature one needs something that core provides. And we need this to get that expensive object. Maybe we need to do something within the feature one activity or so forth, right? Now, when we do this, we have to write a lot of code like this, correct? We have to write Dagger generated feature one component dot builder and provide the core component. Now we have to get a context over here, but similarly, let's take feature two module, which provides an int. Again, it depends on core component. Sorry about that. And in this component, again, we are going with an inject and same bindings and so forth. Now, the problem with all of this put together is that component dependencies, we must follow two simple rules. If an unscoped component is provided, let's say a feature one is unscoped, you cannot really depend on something that is scoped. Core, if you realize, is scoped with a singleton, whereas feature was not scoped at all. So remember in Dagger, if you're working with a lot of dependencies or a component that depends on something else, make sure that you add a scope to your modules. And also remember that a scoped component cannot depend on a component with the same scope. So if I had something like feature one scope, which is added to a feature one component, and we have feature one component magic, which also has the same scope. These two components can't talk to each other. They have to be provided. They will be available, but they can't talk to each other. So let's take that step and let's put it into practice. Let's build something called as a feature scope. Over here, we are writing an annotation class, and we are appending it with a retention of, say, something like a runtime. It depends on your use case. Now, at my feature one level, what I'm going to be doing is I'm collaborating with my component and saying, hey, I'm going to be scoping the entire provisions that you provide. It could be binds, it could be provides, whatever you have within your module, I'm going to be providing it through feature scope. Now, the reason this works is because core component is singleton, but here it's feature. So as long as this feature is alive, I will have a necessity to talk, and I can provide whatever I can. So in feature one, we provided string. In feature two, we provide an int. So if someone says I want that particular string, I'll be able to provide as long as this feature is alive. Similarly with cores, because it's a singleton, as long as the application lives, or the process lives rather, your core component dependency called expensive object will be available to you. Similarly with feature two, I'm adding at the rate feature scope so that this feature is alive as long as this feature is retained in the source set. Now, when you talk about component or dependencies, we can choose what we expose for each component, correct? We can write, say, something like feature one should expose the string, and feature two should not expose the int. It could be at that level. And we can also keep it a bit more verbose. Within the component, if anyone comes and reads your code, you can say, hey, these are all the exposures, or these are all the exposed components that I'm providing. Now, the feature one component can provide a string, but it could have other provisions that is internally used, and I don't want it to be exposed to someone else. Similarly, with co-component, if you realize we had exposed the expensive object. The reason we wrote that is so that anyone who needs expensive object can just say @inject and can get it. So it's a little more verbose. We can also get dependencies from multiple components when and where required. So in a way, if you have multiple dependencies, the more scale you grow with your dependencies, you can get all the dependencies in. You can actually inject some of those into your component. In this case, you are a feature component. This actually provides you a faster compilation time because this gives everything you need at the time that you explicitly ask for it, right? Next, let's get to binding it all together. Let's take this code that we have written within the application to start the core. And in feature 1 and feature 2, we expose, or rather we expected the core to provide something for us. What we have gone ahead and done here is that to kind of avoid uh, the collisions of talking to context and so forth. If you realize feature 1 needs to expose its context, and I have to literally say I have a binding acknowledgement that I need to provide core component. So from feature 1, we talk to application context and say, hey, give me the core component. Instead, we have a suggestion for you. Let's take this interface as an example. What we have here is a provider mechanism. This basically exposes a function that says I will provide the core component when required. The implementation of this is like this. Now we have an inject helper of sort. This is a class that we use quite a bit. You just have to provide a context over here, and we then take into account if this context is an application context, or if it is not, then we take the context or application context and try and typecast it to see if it is our core component provider. Now, the advantage of core component provider is that we make our application class implemented, and we have a function called provide. So that is where the magic occurs. Now, this inject helper can be written at any level you want. Over here, what we have done is if the application context that is provided is implementing the interface, we then provide you the core component. If it is not, we throw an illegal state exception. So this allows us to kind of also manage state of affairs when we launch to multiple countries. There are some countries that don't have certain things initialized, and we don't want the core that is available to say something like Indonesian market. We want something called core Thailand, for example. And when that happens, we can write a explicit inject helper for Thailand. And instead of having the core available across the entire app, we can manage multi-country within our code base. Yeah, sorry, let's go ahead. Now, what I'm doing here with my application code is that I've implemented my interface. Now that takes a provide function. And in the provide, I'm initializing stuff, and I'm returning the instance variable called core component. Now, the beauty of all of this is that it's a late init. Now, the late init is initialized because in such a fashion is because application process can kick off when it requires. The core component will not initialize until someone really requires something from the Dagger tree. If you realize Dagger tree is where core component is beginning with, correct? Now, if I go further, this is my main activity, say somewhere sitting in my feature 1. Feature 1 would usually, you would write a code like this, correct? You would write something like core component, this being a context here, and dot core component. This is all fancy, but let's take it one step further. A lot of people, when Dagger-Android came out, they were like, what the hell is this? And we never took that route. We actually kept ourselves plain, and we wrote abstractions on top of Dagger.Android. What we did is we, again, created a scope, activity scope with the retention of the class at runtime. And at the app module, what we did is, again, if you know a bit of Dagger.Android, you provide your activities where required, and you write a module that connects the Android support or the injection module from Dagger.Android. Now, what happens here is that we are scoping our bindings as well. We write activity scope here. Now, all of this put together, we also have to introduce something called as has activity injector. And we also have to inject a late init variable called dispatching Android injector. Now, this is done for the activity. Similarly, you could do it for fragments, services, broadcast receivers, and so forth. Now, what we do with onCreate is that we say dagger.create and we inject everything in. Now, putting it all together, you would have to write something like this, Android inject.inject, correct? This will provide all the initializations that we need. Now, this fellow could be used with activities, fragments, services, content providers, and broadcast receivers. One pro tip that you can take into account is when you initialize, say, something like expensive object, you can also do it with lazy. What this means is if the activity doesn't really need it right away at the onCreate, you can also do it with lazy. Lazy is a keyword from Dagger, and when you absolutely need it within your screen flow, you could do something called .get. Similarly, given the time, always go for a static provide method. Nobody cares about the name of your scope, so you can be very pragmatic about it. Expose the application context through a component builder instead of a module that generates a constructor argument. Or even better, use a new factory method that Dagger provides. Now coming to the feature module, if you realize we have something called provides. What if you make it abstract? Now the beauty of this is we can take provides and move it to a binds kind of a logic. Now what this provides is that a provide has to talk to the component, it has to talk to the module factory that the module is providing. Then it goes to the module, and that is where the initialization code is written. That is where you write a bit of a boilerplate for initializing your dependencies. Now, this then goes to the module factory and then provides the component and then goes back upstream, correct? This is one way of looking at things. The other way of providing a dependency is by writing at the right binds, by abstraction. Now, the beauty of all this graph is that you just have to talk to your component and say, hey, I want this dependency. It creates everything inline and provides it right away. So it's a lot better. Next, you can also do something called into map. There's a lot of multi-bindings that you can do with Dagger. This is very useful for, say, something like if you have a lot of shared preferences, or if you have a lot of view models, or if you have a lot of common homogeneous type of data and you want to be provided at runtime. Few more things. Provide dependencies through class constructors. Avoid field injections. Just a pro tip. It solves a lot of things for us. Avoid unnecessary scoping. If there is scope annotations, be very judicial about it. Next, use reusable components. Again, as mentioned before, it's a little more expensive, and try and be more immutable dependencies so that it can be handled better and it will be a lot easier for you to manage. Use binds over provides, and also write test for your switching dependencies. You can actually write unit test for your Dagger graph. There are a few resources out there that you can go over. There are a few things that I'll obviously be sharing the slides with you. And if you have any questions, the forum is open for you. I'll be available throughout the day. A little bit about Gojek. If you're looking to know about what we do at Gojek, and if you want to see some of the source codes that I shared with you and some of the pro tips, and if you want to read more about us, you can obviously hit our websites. Superapp is where you can find more about Gojek, and Gojek.io is where we share most of our engineering blogs. With that, thank you, folks. You can find me on this website, and the slides will be available for you at a later point. With that, I would like to thank you guys for sticking with me for this course. I'm sorry I had to speed up a bit during the course. But if you have any questions, I'm open to answering them now. Okay, so we have a few questions. Do you have a different Git repo for each module? Okay, great question. Actually, we don't. We used to have multi kind of a way of writing multiple repos. We use GitLab. We don't use GitHub. We use GitLab. So we had multiple GitLab repos. With a recent, back in 2018, what we decided was our consumer code base was increasing. The release scoping was very hard. The release engineers had to manage everything together. So we brought it all together and we made it into a monolithic repo, but with multi-module architecture. Okay, I hope that answers. Okay, moving on to the next question. Do you have a kind of sub feature that is used in other features? Yes. So there are a few things that so we have a lot of products. If you realize, we have 20 plus products. So we have one product that then has certain screens that are split into submodules, if you like to call it. Now, the dependency graph between them is managed internally. We have a lot of interfaces that this parent module then talks to the internal submodules. So you can obviously do that. You can have multi-modular even at a granular level like submodules. Okay, with that, a few more questions, sorry. How does app module know feature modules? How to communicate and navigate between different features or screens if they don't know each other? For example, going to a screen A after login. So what we do is we provide all our dependencies from the core level. So we also have a deep link handler that provides us a way to say, oh, okay, there is someone who's going to be, think of it like a registry pattern. I'm going to register myself as a feature A that this screen can be handled by me. And this is the deep link that you need to call to talk to me. So when feature A is talking to this expensive object in my example, we are actually providing a registry, or we're registering to this registry and saying, this is what we're going to be initializing with. And that is the entry point. Now, if you realize in my slides, I said, always have a single entry point. So for us, that screen deep link is what we navigate through. Sorry if that doesn't answer your question, but then we can take it offline. I'll be available across throughout the day. You can always reach out to me, or you can reach out to me on Twitter, and I'll explain it more in depth if that's okay. Okay, so moving to the next question. If you have not yet used Dagger 2 or Dagger-Android, should we wait for help now? To be honest, this is my personal opinion. If you have never used Dagger.Android, just avoid it, because anyway, the support for it or the active development has stopped from both Google and Dagger, the maintaining team. I would recommend that you look towards Hilt. Given that at Gojek we have a lot of legacy code, if you can imagine, we have a lot of services that we write within our code base. We are slowly going towards Hilt. So if you've never looked at Dagger-Android in your self projects, I would say just avoid it and just take a look at Hilt. Hilt is a lot more easier to initialize. A lot of the boilerplate is condensed down to all the things that I've shown today will come down to just about one line of code. So it'll be a lot easier for you to manage. Okay, sorry, moving to the next question. Again, if your question is not answered, please reach out to me on Twitter and I'll be available. Okay, the next question asks, say feature one wants something from app. Does it first go to core component and then it delegates to the app components? No. If it needs something from the app, so if you realize app doesn't really provide anything, it is just there to bind everything together. So if feature one needs something, it talks to that particular dependency. So if you realize my feature one component depended on core component, there could be something called auth dependency, auth component that is a Gradle module sitting outside app. App is, if you realize, app is where everything binds together. So if you have an auth module and this feature A wants something from auth, you can actually depend directly on it. You don't really have to go through A. If you realize, I had made a point that higher mod or high top end or rather the highest module should not know anything what the low end is doing. So keeping that in mind, I would say, what are dependencies you have? Core is something that you can depend on, and it's easy to manage the graph there. So, or something like say auth or so forth. But to answer your question, app would not provide it. It's not advised to write anything that app provides. It's just there to bind everything. I hope that answers your question. Sorry, moving to the next question. Can multi-bindings in your given architecture be shared among multi-modules? Okay, so if I got your question right, so you're asking if, okay, so if you have multi-bindings, yes, it is possible. If you scope it right, what I mean by that is when you write, say, something like a view module and you write everything like contributes and you provide @binds, you write @into map. Now, what happens here is that you're actually telling to the Dagger tree that, hey, this is provided as long as this scope is alive. If you've tagged it with a singleton, it's going to be provided as long as the scope is available. If you recall my point, please scope your dependencies where absolutely required. If you don't scope it, it's unscoped bindings, and it could be that it's destroyed even before your requirement comes to life. So a lot of those multi-bindings are, if it is scoped, it's better. Okay, sorry, moving to the next question. Feature modules, dynamic feature modules. For Gojek, not yet. We're slowly progressing towards dynamic features, especially with our Gojek 4.0 consumer app, which is live on Play Store as of recently. We redid our design. A few things are being evaluated right now. How do we do dynamic features, especially with our app being used in multi-country? A lot of the features are not live in most of the countries, so we are looking towards it. We are not live with it yet. Yeah, sorry. Next question is where feature-specific activity modules are kept. Oh, sorry. Oh, sorry, I skipped a question. Let me rephrase. Do you have a plan to migrate to Hilt or use Hilt for the new module? Oh, yes, definitely. We are starting to write a lot of, quite a bit of Dagger Hilt slowly for newer small features, testing the ground. So if you realize that at Gojek we have a huge scale factor, anything that we write will go out to 1 million users. So we have to be very careful with our dependencies and also how to manage it. So we are very cautious about using it yet in production. But it is production worthy. You can definitely try it. Okay, next question. How do we pass data and the deep link when navigating to different features via intent? Yes. So if you use something, say, we use a tool from Airbnb to use our deep links, you can actually pass metas around with it. What I mean by that is that deep link can have parameters, and that parameter gets passed around with a bundle sitting inside an intent. So if an intent has, we also add a lot of attributes on top of this intent bundle, which the deep link doesn't provide. Say something like auth, the deep link would not provide the auth. It could be a deep link to open, say, shopping app, and it doesn't provide auth. So, and that screen needs the auth information to authenticate upstream. So we would then append it at runtime. So the deep link handler as a class will then take it for you. Okay, next question. Okay, where feature-specific activity modules are kept in feature or an app. Feature specific are supposed to be kept in their feature itself. So we keep everything within the feature module, and we try and avoid adding anything to the app layer. For example, okay, just to continue. For example, where is the below code? At the rate activity scope, at the rate contributes Android injector, fun contribute cart activity, feature activity. You can keep it in your feature module. This is your Dagger module. You can keep it within your feature module. And the way it works is that Android Dagger graph sees that there is something else. And if you recall, Dagger is a compile time library as well, right? So it will recall, so it will realize that there is something in your feature and it will contribute, and your activity will obviously get the dependencies it needs. With that, okay, there are a few more questions. Okay, uh, are intermodule communication navigations handled only through deep links? Deep links is one way. There are a few other ways that we operate, and few, if I can recall right now, are we obviously have, say, something like sub features that then talk through intent based system. We also have a bit of a broadcast receiver challenges. What I mean by that is that we have few screens that don't have an entry point. They are driven by an event. So we have a lot of event bus systems as well invoked when required. Okay, moving to the next question. If feature one wants some info from feature two, is it necessary that it will be alive entire duration with feature one? Or is there any other way of doing it? One tip that I would say to you is that don't combine feature one dependency with feature two, or do not depend on feature two. Rather, if you have some communication that feature two needs, I would say that uh, take a core or take something that binds it together for you. It could be the app that does the bridge for you, right? Now you ask a very peculiar question. It's very interesting that how do you keep the scoping alive? If you realize from example, I did the at the rate feature scope. So as long as the screen or an activity is combined or rather used, that particular dependency will live in the Dagger tree. And as you move to feature two, or if something from feature two is needed, uh, since feature 2 doesn't have its life cycle yet started, or if it is not managed by feature 1, then you will not get that dependency. So that's why we try and avoid it. um, if you have anything specific here in this particular question, please reach out to me offline. I'll try and answer you. With that, I have two more questions. Sorry if I have time. The moderator. Okay, cool. I'll quickly just run over. Hilt doesn't support library-only projects. An app shared as SDK to other apps. What is your opinion on that? I would say that, see, when you write a library dependency or you write a dependency for a library, you don't really expose anything through a Dagger graph, right? Or you don't expose it through a DI. Whatever you need to initialize, right, interfaces that then the client SDK or the client app can then talk to your SDK with. Why do you want to depend on Dagger for this? Why can't you expose something that maybe you can call a function in your SDK that the client can then talk to, and the Dagger tree will provide it when required. So you can have an interface there. So again, sorry, this is a short answer, but if you like to take it further, I can definitely look into it further with you offline. Next, can we use Dagger old, and this is the last question, sorry. Can we use Dagger old and Dagger.Android in the same project in different modules? Any challenges around that? So if you realize Dagger.Android is just a separate package, or it's just something that provides the initialization graph for your Android specific components. It could be activities, it could be services, fragments, or whatnot. So there could be some parts of your code that don't really depend on Dagger.Android, and it will still work flawlessly. There'll be few hiccups here and there, but then that's because when you have cross link problem, or for example, a non-Dagger.Android component talking to something that Dagger.Android provides, then obviously you'll have a few complications, but you can foresee it way before you even reach that point. Um, I think that's the last question, unless we have any more. Sorry, I'm also out of time. With that, thank you so much for joining. I'll be reachable on Twitter and throughout the day. Thank you.